Yeah, good evening, all of you once again. So it's a pleasure for me, and it's very nice that it's very good we have with us Professor B. Yegnanarayana sir giving the keynote lecture, and we are very fortunate at IIT Tirupati that he is here, an adjunct professor here at our IIT Tirupati from the last few years, and before that he was there at BITS Pilani, Hyderabad, and also at IIIT Hyderabad for over 10 years, and at IIT Madras as professor for over 26 years, and IISc Bangalore. He is a faculty member for over 12 years, and he was a visiting associate professor at Carnegie Mellon University for over 3 years. And before any of us would have perhaps heard the name artificial intelligence, he has authored a book on artificial intelligence and neural networks, Prentice Hall of India Publications in 1999. Okay, so there might be some of us who are not born as well, some of you. Okay, so and he has guided over 30 PhD students, 42 MS thesis, and many hundreds of papers. And we are very fortunate to have you here, sir. Thank you.
Thank you. So I suppose you can all hear now, and maybe you can switch off that projection if you don't. I have no material to project, so I am the actor, so you have to watch me. Okay. So, all right. So let us start. You see, when Professor Ramakrishna invited me to give a talk, and I just asked who are the audience, what is the topics, and so on. But he gave me some idea, but he asked me to give a general talk. That is all I can do, because I am not. I retired from service formally almost 20 years ago from 18 years ago from IIT Madras, and 10 years ago from IIT IIIT. But all the same, fortunately, I still do some work on my own, and I do keep track to the extent possible whatever. So what I propose to do is, in the next 1 hour time that they have given me, to talk about what we are not doing. What we are doing, all these people are explaining, you see, and what are the challenges in these last 2 talks. I heard excellent talks. So what we are doing, what we need to do, that. So what I propose to do in this, in my presentation, is to highlight what we are not doing. You see, you may say, why? Why do you need that? Because I retired, and I am only not very active anymore. But you people can't say that. You are not that lucky to say. You have to have another 30, 40 years in front of you. So you have to worry about what we are not doing, you see. And so most of the things, of course, it's not that I am randomly saying. I do analyze if things, maybe my views are not in tune with what most of you have, which is good. That's why it turns no. And second thing is, as it so happens, of course, in my case, although I have not done anything very great in all these subjects, because AI has been there for a long time, and I was lucky to almost rub shoulders with all giants in AI over the past 60 years. That is the only qualification I have. Not that I have done anything great in this. Of course, once in a way, I have a couple of times, maybe at IIT Madras, they asked me to give a course on AI 40 years ago, and I gave some talk. That's okay. But that AI has nothing to do with AI now. And this AI will not have to have anything to do with AI 10 years from now. You see, so you can almost be rest assured. I mean, there's no question, because all of you have seen only 2 decades or 1 decade. I have seen 6 decades. So that's why change is constant. You see, that is what you have to understand. Keep ready, because it is not that what great things are happening, what great things are not happening. That's what we have to. And for that, it so happens that, of course, one thing that doesn't change is a human being. That means we are still some 5, 6 feet and so on, and They have not changed over centuries to suddenly 10 feet or micro miniaturization 2 feet or 1 foot and so on. So they are same. And also, I don't think the number of neurons here are not have changed either. You see, nobody has counted. We are estimated is 10 to the power of 100 billion neurons and so on. Knock off 1 0, it doesn't matter. Nothing happens. For me, some neurons have already gone. So that is the whole point here is, this whole workshop from the program I saw and also my discussion with Professor Ramakrishna, I was told, is around learning. So I would like to take that as the theme of my talk, still learning. And notice that learning, as far as this program is concerned, I may be wrong. You can correct me after my talk. But I thought learning related to machine. That's why we call machine learning. At least majority of this discussions here are on machine learning. And then, of course, the so-called words, supervised learning, unsupervised, self-supervised learning, and all kinds of things, reinforcement learning, what more are there? Many more learning terms that have come, and that is and transfer learning. Some more learning now words will come along the way. You see, all applied to the machine. Yes. And all this that we are doing, we are simply calling it an AI. Please note that. Please, very important to understand. We are not defined what AI is. What we are doing, we call it AI. That's the point. Very important point to understand. Again, my talk is just to provoke you to think beyond this. At the same time, I have this 80-20 rule. What is that 80-20 rule for everyone, especially researchers like you, youngsters like you, who are active up to 50 years, at least I am assuming that all of you will be active. Afterwards, not that you will taper off, but you will make others active. So the 80-20 rule is the following. 80, you do whatever we have to do for the technology, follow the crowd kind of a thing. The 20% mental activity, you sit separately and see, what am I doing? Why am I doing this foolish thing? See, like that, you should be self-critical on this. That will generate beautiful. Just keep writing. Don't have to give a lecture on that, you see. And so, unless you have that, if you put all your 100% on there is a danger. You see, all your training that you are taking now, after 10 years, you are not wanted anymore, because the training is useless. That 20% will help you to adapt to the new one and so on. You see, that's the philosophy. So learning, and now it is whatever we talk about learning is related to machine, and all the learning, whatever you do with that machine learning, we call it as AI. That's why it's called AI ML, if I am right. AI ML. Right from 8th standard onwards, it goes now. Right up to PhD level, everybody is AI ML. You see. And degrees are also with AI, ML and so on. That's fine. I want to provoke you to think what is not done here. That's the point. First, let us start with the whole focus of my 1 hour talk is about learning. Focus is on that. And learning, unfortunately, has nothing to do with machine. Learning is a human attribute. First thing we have to understand is learning is a human attribute. And another very important thing is learning. Please note my English. Learning is not learn or learnt or learn. It is simply learning. What is that? It's a continuous thing. It's a continuous thing. That's what human beings do. So just to, all these words got mixed up over 40, 45 years. Thank God, I have to teach. I don't have to teach on this, but otherwise I'll be shaking in a class. I don't know what meaning or things that I have to give for these words: learning, knowledge, and intelligence. These 3 words: learning, knowledge, and intelligence. All these things were there some centuries ago. It's not that you have invented now. And they are all human attributes. So the whole summary of my talk is how those human attributes are looked at in the context of machine. That's the point, you see. So this is what and before and of course I don't have slides, because since morning I was thinking how to organize my thought, but I couldn't come up with a great structure. So you have to put up with answer. And another thing is, the message I want to convey, the moment I put a slide, that message is lost. You see, fundamental thing. You think that we are doing great things by a slide. Every slide destroys the intelligent part of your presentation. You see, because it is not letting you to think. That's the point. You see, that is the reason why I have not used slide. Of course, I also don't know how to use the PPT and so on, but I can take help of some of you to prepare them. But that's not the point. So in the I want to organize this into 5 sections. I don't want to write it on the board. Let us start to talking about pattern recognition that all of us know. You see, this supervised and unsupervised came. Pattern recognition, when you say it is statistical pattern recognition, that's what all of us talk. Syntactic pattern recognition has come and gone with case foo. So it is not there Purdue professor and so on. So it is all statistical pattern recognition. But, and then the second point I want to discuss here is the evolution of this AI, whatever you want to call it, the AI, over past 70 years. That is, from for want of a better name, I can put it in different ways. Evolution of AI from intelligence to AI, or from learning to deep learning, or from science, engineering, and technology. I can talk in any of these domains. You see, that's so evolution of AI. That's the second topic I want to touch upon. The third topic I want to touch upon, which is very important for all of us, because we refuse to think most of the time, it looks like. And it was, I don't know how many of you know R.W. Hamming quotes and so on. You heard about it, Hamming said, machine should work, humans should think. That's what Hamming said. But now we are letting machines to think, and we don't know what we should do. We are not supposed not to work or something like that. I don't know. Anyway, so the whole point is the third topic I want to take it up. In fact, so evolution of AI, please, whenever I say this, Blaze, don't attribute any expertise to me. I'm not. But it so happened that I went through all of this. I was a student in 1950s, and from then on, moved to this, and met some of the giants in this field. Not that I interacted with them very much, kind of a thing. So I want to highlight that. And so the evolution of AI that led to what we are today, you see. And so that is this second point. Third point is the distinction between human learning, not machine learning alone, human learning, learning in ANN, and machine learning. They are very different. Please note that. Very, very different. You have to understand it. So that's why you can see what we don't do, what we don't know. So I am distinguishing human learning, that is inherent, that has been there for centuries. There's no question about it. In fact, people learned much better earlier than what we are doing today. So human learning, learning in ANN. My perception is, I may be wrong. Please don't mistake me for some words. I am senior enough, to say that, and senior enough for you to pardon me on this. So I use certain terms which are, you see, human learning, learning in ANN, which in my opinion, many people whom I talk to, nobody knows what it is. And then machine learning, very different, all these things. So that is the third topic I want to briefly discuss, you see. And the fourth topic I want to discuss is what is called it should be fifth topic, because first I said pattern recognition, evolution, okay. Third one is human and machine contrast, human, ANN learning, and then machine learning. And the fourth one is, these days I have been looking at this topic much more seriously, but for myself, that somebody provokes me to talk about it in some forum, so I do keep saying that the missing science in AI. The missing science in AI. You see? So these are the 5 topics I intend to cover in the next 40 minutes or so. That's what I propose to do. And all of you are welcome to ask maybe at the end of my talk, because we'll discuss openly some of these things. So let us start with pattern recognition. I asked a lot of the guys in, all of you heard Indian Statistical Institute, Calcutta, and also you might have heard the name C.R. Rao inequality and so on. I talked to these people, and there are giants and I said, what is a pattern? No answer. You have that is correct also. Please note that. What is a pattern? No answer at all. Now quickly go and refer to all your dozens of books on pattern recognition. You will never find a definition for a pattern. You see? And so the pattern recognition that you talk about in books and treatment, statistical pattern recognition, all these things is a pattern. There are one view of this, but there could be slightly different views and so on. The pattern recognition is a statistical pattern recognition. A statistical, there are exceptions, please note. So statistical pattern recognition, and most of the cases, although they refer to what is called the common feature space. A common feature space is what you talk about. That is why when you talk about a classifier, you are talking about how this class features are different from this class feature. That's what you talk about. You see? And of course, the regression and so on. And somewhere like Bishop's book and so on, they keep on saying, oh, one leads to the other, be classification, regression, they explain them in the same framework. That's all fine, but there is some, this is not the forum to argue, but if you deeply think, there is something amiss there. There is something wrong there. You see? So classification, let us just, I'm not going to spend too much. So the fundamental question here is, it is a common feature space. Already you have diluted the problem completely. You see, if I have to distinguish you from you, I may use some features. Distinguish you from you or you from somebody else, I may use some other features. So the features that you use are different, and by throwing it in, because why did you throw it in a common feature set? Because I want to use statistics and distribution. So it is that tool that forced, the tool means that concept that forced us to look at it, but in the process you have already destroyed the problem. That's the most important thing, you see. So, and it is also interesting, although we have, these are the thoughts I am collecting, in fact, especially last one year, last 1 month, last 1 week itself, I have made some notes on this, but so my thoughts are not well crystallized. But having said that, I thought Ramakrishna has given me a forum to talk, let me talk. You see, that is the way I looked at it. So, if you take, let us say that feature space itself, let us say one class some class, and other classes, you see. Typically, as I told you, this class, many other classes that you have, you want to compare with, the one class, maybe there is a commonality that is called the descriptive features. That is a descriptive or generative features that is likely to be common, reasonable to expect a common feature space. But discriminating between classes has to be different features. Why? It's like a ruling party and opposition. You see, even these days ruling party also oppose each other, that's a different matter. Assume that ruling party, they are supposed to have some underlying philosophy. Try to, these days they jump the ship very quickly, but let's not worry about those fellows. But just what is opposition? Just because opposition name is that they don't belong to one class. Same point works in pattern recognition, and we never do that. Very important. And another very important thing in pattern recognition is, you see, that the so-called feature, we force the feature on the data. That means some kind of a representation, and that you use it as a feature. Good, that's not a problem at all. But human being, the beauty of that is the feature that you see from the, let us say, from pixels of a face or something like that, is very different from different people. are different persons. You see, so the feature that you extract is very different. But let us assume that the feature is constant here. So that is the pattern recognition. The way, that's why I was asked to give a talk at by Professor C.R. Rao. You know, he's a great giant. He is now running 102 years in Kramer-Rao inequality and so on. He asked me to give a talk in the statistics department of Penn State in college in US, and I was just hesitating. Giants of statisticians are sitting there, and I am asked to give a talk. I was scratching my head what to do. I say, I'm not a great statistics man. And the topic I chose was why pattern recognition is not a statistical problem. And I gave a talk. C.R. Rao was my host, and at the end of the talk, C.R. Rao said, if you listen to Professor Yegnanarayana, nobody will get any funds. See? So that was the, so it is true. If you take a human pattern recognition, it is not a statistical problem. I don't have time to explain that, but it is not a statistical problem. And just to digress a little bit to see, not exactly matching, but since all of you are talking about machine learning and dimensionality reduction and so on and so forth, all of you have done PCA. You know what is PCA? Principal component analysis. You have done that. So you collect large number of face images, of course, crop them up to 32 by 32 or 164, whatever it is, and then you collect eigenvectors, eigenfaces, you call it, two-dimensional eigenfaces. You see, and what somebody said is, okay, you take 20, 30, 40, 50 projections onto the eigenfaces, you get the person's face representation. Am I right? I think I am right there. But we are all wrong there. The real face is after removing that 50, first 50 you have, I don't know if you ever have looked at it. If you ask a person to recognize a person, I have done this experiment myself. If you ask a person to recognize from the projection on the first 50 or 25 or whatever it is, because all the variance is taken out into the, and the resultant remaining part, you see, that is where you can recognize a face, recognize an individual person. Beautiful. You see, the same thing works in speech as well. I am not quoting speech because which is what my field is, but it is exactly the same. That's why the residual type of a thing. But it's like a sour grapes kind of a thing, Since you don't know how to handle that residual, both in speech and image and so on, you say it doesn't have any information. Don't even look at it. So that is the pattern recognition part of it. There are many, many stories about this. So I have indicated a few of them. Let us move to the next one. You see, that why I am saying pattern recognition? Now we are saying that AI does something like, that's why I mentioned initially, supervised, unsupervised. For a human being, if you are not heard this, if you are not an electrical engineer, if you are not joined IIT or something like that, or engineering college, or if you ask somebody in the road who does some other discipline like music or English or whatever, or some other field, let us say architecture or something, you see, and you ask him this question. What was the question? I forgot this string. So he will not understand what you mean by this. I forgot that word. What was I talking about a minute ago? Huh? Supervised. Sorry. Thank you. Just sequences. So if you talk to them, supervised learning, unsupervised learning in their daily life, do you get any answer from them? It has no meaning for them. In fact, for a human being, there is no meaning at all. In our whole life, we never do supervised learning explicitly. We never do unsupervised. Whatever, we had to break them into this category of problems and supervised learning, this category of problems and unsupervised. Otherwise, Same thing with reinforcement learning as well. We use it all the time to learn, but we never called it as reinforcement learning. If you start categorizing your daily activity into as a human being, you are in big trouble, because it doesn't capture all that you are doing in a daily activity. You see, we do learning a human way, but none of these are applicable there. But for our pattern recognition, this one, we need to call this as supervised learning, unsupervised learning. That is how, you see, the reason I am saying, somebody says, very simple, okay, what is that? And labeling. You give the label of each category and so on. Why do you need label? Because I want to train my neural network. See, I'm stuck with this. So I have to train that. So I need to labeling. And now a lot of papers are coming in mislabeling or wrong labeling or confused labeling and so on. Hundreds of papers are coming on. See, this is all nice to generate lots of papers. You see, but who asked you to label that in the first place? For the, because you want to apply the machine learning. I'm just saying, just so that is the, so the evolution of the second topic, that is about the pattern recognition, the evolution of AI over the parts to this one. You will be surprised to know, see, poor fellows who thought about AI 60, 70 years ago, they never, fortunately, all of them have died. See, that's why none of them are available to discuss. See, otherwise, they will get a heart attack and they will die. See, that is our current AI. You see, I'm not, please note that I am not disputing the effort at all. I'm only talking about, because unfortunately they were born 70 years, proposed it so many years ago, and we are using the same term. That is what they would complain. You see, the AI, we almost forgot I part of it. You see, what almost? I don't think, if you ask even among us, let us take a equivalent of a Turing test. Let somebody sit as a judge and you call one by one and say, what is mean by AI? You ask all these 30, 40 people, no two answers will be correct even up to 20%. You follow what I'm saying? So this is the, so I will tell you briefly, another, just because this topic alone I can spend about 10 hours. So I will spend in 10 minutes or less than that. You see, evolution of AI, it started, there is an inquisitiveness to understand. When you say you are more intelligent than him or something like that, how do you measure this? Of course, intelligent is not a relative thing, kind of a thing. In absolute terms also, when your activity displays some kind of an intelligent notion perceptually for the person, what is that intelligence you are talking about? That was the question in Dartmouth conference those people addressed, 1955, 56, around that time. That was the one where AI, if you carefully read their course, what they said is, all aspects of human way of doing things, if you understand, we should be able to demonstrate it by a simulation. There were not great computers at that time. You see, that means your understanding is more important. That is science. And science, intelligence, so you attribute the word intelligence, doesn't matter. That intelligence is a natural process. Intelligence is always associated with a natural process. Please note that. And so the natural process that you display, they call it as intelligent, and they are scratching their head. Can we? So the whole idea was not to build a machine to demonstrate all this. No, they were not interested at all. They were interested only, can you understand as much as possible what you display, your human ability, called intelligence. That's the Dartmouth conference goal, AI. And then slowly in those days, computer, some, only in the most advanced countries also, they have only a few batch machines and so on. So they were not thinking of building a machine and which can do all these things and so on. So that is the, so then what happened was, computers are getting slightly better, at least in other countries, you see. And so then some big shots, like for example, Alan Newell and Herbert Simon, I happened to just spend some time in their lab, although I just shook hands with them, but I don't know much about what. They wrote a book on human problem solving. They are called Father of Artificial Intelligence, Carnegie Mellon University. And so that means instead of, then they switched slowly the attention from what is at Dartmouth conference AI was proposed to the machine. Then they said, okay, machine, was doing a numerical manipulation. Machine computer means compute numbers and so on. That is what it was meant. So, computer doesn't compute numbers. You are interpreting the manipulation of bits as an addition, subtraction and so on. Otherwise, it doesn't do addition, subtraction. You are interpreting the manipulation that is done in a machine in terms of on-off states represented by 1 and 2 as numerical computing. Please note, I think all of you are seniors, so I don't have to say that 1 and 2, 1 and 0 have no numerical value. It is only a representation of two states. Please understand. And also, sorry for sidetracking once in a way like this, the so-called word bit. So everybody uses. I ask so many students, what do you mean by bit? All of them give promptly the wrong answer. That is a binary unit or binary. It is wrong. It has nothing like a numerical addition. In fact, if you want to abbreviate the binary digit, it is called binit. Binit is the abbreviation. Bit has a specific meaning of information. That's why you cannot use that. And now it is also called Shannon. So that is, please don't, of course, since everybody is using, in our village, Nehru is called Gandhi. So like that, you can call this whatever, you see. So it doesn't matter. So the whole point here is, that is how this Alan Noel and Simon in the AI evolution, they thought this manipulation can't be interpreted like symbolic manipulation instead of a digital number manipulation. That is how once you manipulate symbols, it becomes a logic. You can draw inferences. Like, logic books. I took a course in logic in 1950s, for my BA degree. So, and of course, I forgot all of that. The logic means inference, that is a human effort, human ability. You only can do that. So they said, why can't I develop a machine to symbolic representation management? That is the real starting point of AI with a machine. You see, that it was in early 60s, you see. And then, of course, I don't want to go through all of that. That will take several hours. Then what happened is, AI is side business, something is happening. All of you have heard what is called Rosen. Everybody, human being is always a curious person. See, in what direction you are curious today? So everybody wants to understand this unknown thing called the brain. And I keep telling, God has designed this in such a way not to be understood. You see, if you understand that, you don't feel like living. That is the problem. You see, he has encapsulated. So everybody is like a white elephant, a blind man and wild. Everybody, I understood human brain kind of a thing. This is this is how we started. In fact, although it must have been even earlier. If I keep track of it, 1940s is one Hebb's proposed Hebb's law. How the learning takes place in biological neuron. That anyway, all those stories are. So Rosenblatt, very important because it relates to somewhat Professor previous talk, what you have presented, and also related to what Ramakrishna has presented. You see, and link may not be perfect, but I think it triggered some thought in my mind. You see, with what Rosenblatt has said. Rosenblatt is the one who proposed a perceptron model for neuron. What is a perceptron model? Weighted sum applied a threshold. Please note that. That is only to biological neuron is firing and not firing, nothing else. And of course, you can approach. So, understanding a single neuron itself, several Nobel Prizes have come. You see, understanding the brain of 100 billion neurons, I don't know how many Nobel Prizes will come. You see. The point here is we don't understand how and notice that whole thing. Of course, I will come to the next topic, what I am talking about, but in the learning part, but since I am on this topic, so Rosenblatt had proposed a perceptron model and built a machine which can recognize certain symbols, let us say characters or something, automatically. It learns. That means you show the symbols or characters, let us say, and the machine, next time you put another one of those 26 characters, it will recognize that. It has a hardware that was built and put it in an exhibition. Everybody was thrilled. This was in mid-60s. You see, and in fact, the perception at that time was, notice that there were digital computers, but still I was a student in early 60s, so I worked with analog computers only. Digital computers, we couldn't have that luxury of this. Lots of stories to tell about it. Let me not do that. So this is Rosenblatt. When he proposed that, he had said something else which all of us ignore, and that relates to what Ramakrishna and I forget your Sunil, Santosh. You presented this stuff. So sorry for my wrong. So Rosenblatt has proposed the input to the perceptron is not the sensory input, is not the samples of the speech signals. Input to the perceptron is the output of association units. And that association units means, imagine there are so many blocks, association blocks kind of a thing. It looks at the image and one unit collects data from our pixels from some 100 of them, let us say out of 1,000, and another unit collects another 100, not in a sequential manner, in a random fashion. Random means it is not random. So that is the association. In fact, the beauty of that is the functioning of the association dynamically changes. For one image you see something, next image or next instant the same image, association units change. But we left that. We struck off that association unit from the our dictionary, you see. Although I put it in my book, I have to strike off sometime, otherwise people don't follow, you see. And so that is the problem. Right now your convolutional networks, you say, oh, say average this, and then of course whatever it is, I don't want to use our terminology, and so they're all fixed. So you can see, as long as you use that fixed, you can't get the kind of a result that you get from a biological system. That's the point I want to. I'm not evaluating and saying this is better, that is that. That's not my intention at all. My intention is to analyze and see what it is. So this is the evolution of this. So perceptron, and of course thanks to Minsky and Papert. If any of you have not read that book, you should read that. It was published in 1969 because there was a euphoria in that mid-60s that digital computer may never come. You see, they thought this whole thing, based on perceptron, you are able to solve problems. This is the model of computing. So they thought there was a euphoria, but suddenly these fellows, Minsky and Papert, they don't keep quiet, They just work on this mathematically for 2 years and published a book called Perceptron. That's all. The whole excitement Rosenblatt has created died immediately. It was a step function. You see, once that book released, then they said dump perceptron. That's all. That is what has happened in that. But it's an excellent book to read. It's a highly mathematical book too, but very beautiful. And anyway, so perceptron. Let us leave that, because they came even in our here presentation, so I was referring to that. Otherwise, my intention was not that. So then what happened? In 70s we go. Symbolic manipulation, lot of everybody was engaged. I don't know whether you heard a name called Hans Berliner. He was a great chess, not only chess player, but chess programs he has written. In those days, I am talking about 50 years ago. He was at CMU. I met him also. So anyway, that's it. But 70 something has happened. Lot of things have happened. I will briefly. 70s, what happened is, the symbolic manipulation, they kept it aside. Computers are getting more powerful. So they wanted to know whether you can demonstrate the ability of human intelligence in a machine. So they are more focused on machine. So, and they said, okay, games like puzzles, chess and so on, they are board games with specific moves as operations. So that can be represented in a machine. So they put it, the intelligent part. We are suppose you are a great chess player, so you are more intelligent than me. That is the impression. So that is they are able to simulate by means of as such a problem. So intelligence became a heuristic such problem. And that heuristic means is not a blind set, brute force set, but only at every time somebody plays, only many of them are pruned, many options, only a few of them are left. That pruning is called intelligence. And but that's what I used to teach in my AA course in early 80s when I taught, you see, pruning. That was the, but then people didn't keep quiet, you see, and that said, they applied it to image recognition. I am looking at all of you. I can count how many people are here, you see, and I can do many other things. But so that means it is not that processing, image processing, but I am understanding the scene. I am understanding this image. So likewise speech, when I am talking, all of you can, if you want, you can take the dictation notes of what I am doing, you see. And so that is also, you don't really capture all my speech signal and so on. You are understanding the speech and then writing. So that's why the image understanding, you type in Google, you will get it. SUS and IUS, image understanding and speech understanding systems are developed, motivated by the heuristic search and so on. Very beautiful. In fact, it so happened that I was thick in that kind of environment, not knowing what is going on, kind of a thing. But anyway, I just type a few commands on the system and get some numbers, and that's all. I didn't know beyond that. But there was a huge activity, and please understand, beautiful. So symbolic manipulation, yeah, heuristic search, yeah. But then what happened was, even at that time itself, I have to give another example to do that. You see, just again side digression. You have to put up with this kind of a thing. You see, we all talk about natural language processing. You see, when you are listening to me, you see, this is a speech processing kind of. So, and the speech, we always link it up language. We don't have to. In fact, speech is a much higher level of speech is only for communication between two human beings. So that is at a much higher level of naturalness, and which you cannot put it in paper. When you put it on paper, you don't know who spoke that. And without emotion he spoke, without gestures he spoke. And all this also conveys the message in the communication. So that is the natural part of it. No question about it. You see? Now what happened? Thanks to our Google level, and also we follow them. You see, we are always at the back. The point here is NLP. This NLP, I don't mind, all what is that? Some millions or billions, I don't know, whatever number you talk about. For me, all of them are same. So text you take and build a natural language processing. But what are you doing? That natural language is simply a text. And why do you get the text? Somebody speaks. Let us say if you want to do speech recognition, from speech, you ask somebody to transcribe and keep the text and then process that. And they call it natural language processing. But from speech, if you come to text, you have destroyed all the naturalness that is there. You understand my point? And you put a text. And now from text, translation, text to text and so on. And now you want to create a speech again. So you have to, this is hard. You have to plug in the naturalness, put the naturalness back into the, how do you put it? We have all model, dialogue model, this model, that model. That is how we are all surviving. This NLP is a great thing. All the jobs, AI jobs are there. But you can just see, we destroyed the problem. You see, we destroyed the naturalness. And there is no, we don't even understand what is the natural process that you have destroyed. So you can't say that I have put it. Somebody said, no, this professor doesn't know. I listened to the speech. It is so beautiful. It is so natural and so on. Can you guess what it is? That because you are listening, that missing naturalness, you are substituting from the brain. You don't even know what you are substituting. That is the wrong message you are getting by saying, oh, something is happening and so on. So you can see, where is the intelligent part of it here? Intelligent part you have already done by transcribing the speech onto text. You have destroyed all the intelligence in the text, and now you are putting it back into it. You see what I am saying? Why I am putting in this fashion is, it is not that, I did say in the beginning of my talk, it's not that what we have done, but what we have to do. What we are not doing is what I want to highlight. You see? Not that all that I am saying is right, but it was just. So anyway, now let us continue our evolution of this one. Another beautiful thing that has happened, if you notice, apart from this. See, when you talk about speech or image understanding or something, or when you are listening to me, for example, I always distinguish even my signal processing courses. I teach normal, I'm a signal processing person and I work in speech signal processing in particular. So, when you are listening to me, you are not doing speech signal processing, you are doing speech processing. When I collect the speech signal from the microphone, put it in a machine and display it, that is speech signal processing. That is where you are busy writing all the papers. You write algorithm papers and all like this. Mine is better than others and so on. But in speech processing, when you are listening to me, the beauty of that is, you get the signal, this acoustic waveform into this, and you process it. While processing, without your knowledge, because maybe with your knowledge, you are using so much of acquired knowledge that you have about English, syntax, semantics, context, and also the whatever it is on the subject, all that you are using in understanding the speech. Suppose you put somebody else, somebody from the road, let us ask him to sit and listen to my boring lecture. Oh, it was really boring because he doesn't have that background. He cannot put that knowledge into that. You follow what I'm saying? So that's exactly they caught at that time in 70s. That's why they didn't use the word knowledge-based system, but they start injecting the knowledge into this for speech recognizers. And SVMU, MIT and so on, especially CMU, the knowledge you are collecting, I'm talking in the context of speech, image is much more harder to get the knowledge because speech at least there is a production and also some slightly better understanding of the process, you see. So anyway, let us focus on this. So that knowledge, syntax, semantics, prosody and so on, that's why you can see there is a book written, published at that time, Trends in Speech Recognition. Beautiful collection of about 15-20 articles and published by Vian Lee and Jane Chu. Excellent. You see, what is the message that is there is, you have the speech signal, that is input, and you inject all this knowledge onto that to decode the message. And that is Roger Reddy's group in CMU produced at least a dozen PhDs, I think, using this. And of course, I didn't work like that. Whatever system they produced, I started, doing some experiments with that without knowing what they were. But it was, you just see, it's very important to understand. That means speech signal itself is not enough. You have to inject the knowledge into that to decode this. Please, that is the message I want to convey. You see? So this knowledge has to be incorporated explicitly. And then somebody thought, instead of doing like that, can you build a knowledge, go to somebody like a medical expert or legal expert and so on, ask them to call out, to extract get the knowledge out of him kind of a thing, so that you can dispense with him and I use the knowledge-based system and so on. Unfortunately, it didn't stand for more than 4 or 5 years, you see. So, because you can never pull out, when you are saying something, doctor also, how did you diagnose this? Means he cannot tell all the ideas that he may, since you are forcing him to say something, he will say something. But you cannot pull out it. So, knowledge-based systems, expert systems was thriving for 5 years, and I was also chairman of the department at that time at IIT Madras. So, not to lag behind, I immediately created half this room and so on. This is a knowledge-based system, that's a lab. Otherwise, if you don't, and after 5 years, I removed that label. Because in 1986 came the so-called neural networks, PDP volume. In fact, those of you talk about neural network, if you have not done that, you please remember at least the whole field came about because of those 2 volumes in 1986. They are called PDP volumes. Because in NIPS conference, apparently a couple of years ago, there were at least 30,000 people there. In the plenary talk, the speaker asked, how many of you have heard PDP volumes? Not a single hand went up. But unfortunately, the whole neural network field started then because of those 2 volumes. So the neural network displays this expert system. What do you mean by this neural network? It is a model inspired by our limited understanding of the structure and functioning of the biological neural network to display some pattern processing task which Human beings do only pattern processing. You can never do data processing. I give 100 by mobile numbers now. Tomorrow morning I will ask you, can you repeat all those numbers? What do you do? You can. The machine, what 100 million numbers you give, it will just produce it. You see? So human being, on the other hand, even number also. If somebody, your friend says, just a short meeting, oh, note down my number, he'll say you 94499. Oh, you may, oh, don't worry, I will remember. Suddenly somebody says, let's go for tea. 944, what is the other number? We forget. That is short-term memory of the biological process. And so, on the other hand, if the same number, instead of saying 94, if he had said, or if you have listened carefully, it's 944, 188, something, 355, and so on. Already you captured the pattern in it. That sticks you. And on top of it, when he says a number, don't leave him immediately. You repeat that number to him, and also say, also, you see, I also have a similar number there, or whatever number you have, even my friend also, his number is like that. You say a few words linking with that number, it gets registered. That is learning. That is learning of a human being. You capture the pattern and link that pattern to the pattern that we have here is learning. I am coming to that in the next step because I am still in the evolution of AI business, you see. So, ANN. That ANN 86, 80, that transition was abrupt. I think matter of 6 months or to 1 year, that's all. Everybody dumped knowledge-based, rule-based system and jumped to ANN and so on. Everybody, every Tom, Dick and Harry, including me, was talking about ANN and so on and so forth. You see, without knowing anything that's happening. Hundreds of books, including economists, philosophers, civil engineers, mechanical engineers, everybody wrote a book. So I also wrote, why not? So that is what has happened. You see, that is ANN. Please note that ANN philosophy, pardon me to say what you are talking today, the DNN, they are not neural networks at all. They have not a single feature of a biological neural network. You see, just because you have, you see, another very interesting thing I saw in the previous lecture also, you see the model, neuron model, you see, again, that is why I am provoking you to think. Please don't, otherwise that is correct. That is, all of us have to say that. The point I am trying to say is, the moment you take a perceptron model, neuron model, put it anything other than a hard limiting one, hard limiting function, firing, not firing, it's not a neuron anymore. It is not a neuron at all. That is only at the level itself, model itself. And what to talk of the connections and what to talk of learning, all of them have nothing to do with the learning neural network, the so-called DNN that we are talking about. And deep learning is, of course, a tragedy, because the point here is there is nothing deep in that. You see, it is a shallow learning of a deep network. And we do deep learning of a shallow network. That's exactly what happened in ANN. ANN is a small network, but each network is designed to perform a particular pattern recognition task, which you have to unfortunately define, because you build a model. So it is inspired biological neural network machine. So the inspiration for this is ANN model. Don't get confused here. This is ANN. Of course, you can't do it. You don't understand it, so you do. But the whole idea here is, as much as possible. That's why you should always keep that perspective. There are theorems which we all ignore, and students don't want to even look at them. You see, the theorem simply states that if you deviate from this hard limiting, its functionality is lost forever. But having said that, so what your DNNs and other things are, nothing but a large nonlinear models. Nonlinear models is large number of parameters. That is the correct description of that. Why is it that people didn't do it earlier? Because to determine the parameters, I don't have a closed form solution. I have to go to iterative incremental solution, and for that I need, of course, huge machines to do that. That is the reason why it didn't thrive at that point. You see, but of course now If I say this in other forum, fortunately you are all nice people, otherwise they will throw me out, you see. Here the point here is, that is what they think is a neural network, you see. And so anyway, now coming back to the neural network, please understand. So until then, notice, this is in fact first time I am, although I give similar presentation, first time I am highlighting it because this learning conference. All I am trying to say is, until now there is no learning. Yeah, that means I am already in 87, say there is no learning. You see what by learning I mean, so it is when neural networks came, the idea was learning idea came. Learning idea came. Because in fact all of us have a tremendously wrong notions about these things. That is my problem. You see, neural network inspired by biological network with a most important function of a neural network, biological neural network, hence artificial neural network is the step function. Anything else? No. What it does is, you are not asking for a solution to a problem, the solution to a problem by optimizing something, objective function. You are asking for a solution which satisfies all the inequalities that this step function produces. That is why, in fact, when I give a neural network course and ask the students to do assignment, when I give a problem, if all of them get the same answer, they will all get 0. They all get the final, if you give input, all of them will give correct output. But no two neural network that they design will be same. That is the beauty of this. Why? You can see, I ask you to, I might have said this in many forums. So, what is the number between 5 and 10? How many? Yeah, infinite number of solutions. Okay, you follow what? Give me a number which is both less than 5 and greater than 10. What's the answer? So you can't satisfy this inequality. You can only satisfy this inequality. That's what perceptron does. Perceptron has this ability. Very beautiful function. The books written by physicists in late 80s, really very thrilling to read them. But of course, we are engineers, so why should I read? That's a different matter. You see, excellent analysis. You see, so you understand my point here. So the learning, the correct idea. That's why you said, I said human learning. I didn't elaborate on that. That itself takes 1 hour to do. Human now, so there is I am switching to the next one already, but I will continue the evolution part after this. So human learning, you learn only through patterns. You don't have a capacity to learn from data. And ANN learning, ANN is a computational model which performs pattern processing tasks, and ANN learning, which is nothing but finding underline the word, a solution to satisfy all the inequalities that is coming out of this hard limiting functions in this. And if a solution exists, there are infinite number of solutions. That is ANN. And your job is, given the data, to find a solution. Any one of them is okay. And that's exactly correct. You see, for example, I give a problem, reasonably some simultaneous equations or adding some numbers and multiplications and so on. Same problem I give. What happens? No two people will come up with the same sequence of steps. They may come up with the same answer. So the solution is not the answer. Solution is the sequence of steps. And learning is not by the answer, learning by the process. So there are so many ways of putting it. So that is, now I am mixing up the ANN and this one. Let me go back to the evolution again. I am still in 80s. ANN, I am talking about evolution. It lasted for 10 years. You won't believe it, that period I was also very active. I started floating a course on this, 100+ students registered. I told them in the first class, both of us, we have assembled here to share our ignorance on the subject, because I don't know what was going on. You see? And slowly for 10 years it went on. And then what happened? Notice in the 10 years from 86 or 87, 1 or 2 years strike off, doesn't matter, to 95, 96, what happened? What happened was, if you utter a word AI, you will be thrown out. It was such a bad word to use. But before that, if you don't utter a word AI, you are looked at as a tribal. So what I have done, of course, we are all a little clever. All that I have to do is change the label on my door. That's all. My lab is this, my lab is this, that's all. That's why now it is the ANN lab, that's all. And then what happened was, 96, 97 is a very crucial thing. It so happens I am a globetrotter, I keep on wandering around various places. So I saw the first mobile, my friend was using, my host was using in 95 or 96 mobile phones. And that gave a lot of flexibility to collect the data. And with cameras on that, so much of data was there. And so, AI, neural network also is forgotten. Data I can collect, so I can get, machines are getting more powerful, so I can use this data to find, please underline this word, lot of people don't answer this correctly. That is when the machine learning word has come. Machine learning means on a lot of data, find the distribution of these, whatever pattern, data, feature, that is machine learning. If you are given only one sample, what distribution? Whereas for a human being, if I have to recognize your face, I can't ask 1,000 faces to look at first. I need only one face to look at. Can you see? But we are all such a great people, even that face recognition, they converted to data-driven problem. With a large number of face, and I don't know. I get so much of, but all my papers are rejected these days because nobody likes that. You see, you have to have a DNN, you have to have a table, your number is bold, this one greater than the other. That is the way to publish papers. And I review also every year, even now, at least about 20 papers. I think even one is exception, but almost all the 20 papers are like this. And I told them, I don't know, but they said speech word is there in the title, so you are expert, so you read. I said, there's no speech in the paper. Only numbers. That's why in my review I write, can the author explain what is the relevance for speech here? See, that is the trend. Again, please note that, don't get me wrong here, that is bad. No, please, that is not at all the intention here. The intention is that has a complementary role is a different matter. You see, it has that means you are trying to find the distribution of the features, and for that you need data. And so even that ANN has vanished in 97, 96. There is a special issue on Elsevier publication, a journal called AI. I don't know how many of you have heard that journal. And there was a special issue or debate on this around 1999 and so on, about 15, 20 top AI scientists were debates. It's an excellent collection of debate. Very nice, both ways, I think because everybody is confused what to say now. See? But in the process, of course, I have the machine, I have the data and so on, collect. Machine learning thrived for 10, 12, 15 years, you see. That machine learning is, anyway, I will keep aside because it was in 2006, something else has happened. 2006. In fact, when Ramakrishna asked me, I thought I will talk about it because the so-called philosophy of Boltzmann machine, all of you know that, but I want to put it across in my own way, see. And I thought most of you may not be interested, so I changed the topic like this. And it was the Boltzmann machine, such a powerful, all of you should read that if you have not read. You try Hinton and Cisnowski, fantastic. I mean, I can't find a better scientific analysis than that, you see. They introduced Boltzmann machine neural network in 1980s, early mid-80s, when the ANN came, and it was never used. Such a fantastic thing, because you didn't have enough machine. Any amount of power. In fact, I remember my friends in Japan were using 3 to 4 supercomputers to run the data to no, before, of course, fortunately, power doesn't go off. So they could run and get some results for just distinguishing three characters, Badaga, you see. So that is the kind of a thing. So Boltzmann machine was never successful in implementation, but concept. But in 2006, that guy Hinton, he doesn't keep quiet. What can you do? He produced a fantastic approximation, which is so good, called restricted Boltzmann machine. I'm not interested in that. Boltzmann learning philosophy is introduced here, but that restricted Boltzmann machine is the one that forced him to use the word deep learning. That is the origin of deep learning. See? And that is the correct. So that means for about 3-4 years, that was thriving like anything, deep learning. Suddenly 2012 or something, that or data, digit data, something, somebody, or image data, somebody get some percentage bigger and so on. Everybody moved to that. They dumped that deep learning and called this a deep learning. You see. But of course, in the meantime, Hinton got his Turing Award and so on. That's a different matter. So, for his work, the point I am trying to say here is that was deep learning. And I don't have time to explain, but what that does is you can exploit the characteristics of descriptive and discriminative learning in building a system, which was not the case earlier. A classification requires a discriminative learning. A recognition, face recognition, requires a descriptive learning, which Boltzmann machine was. These two ideas could be combined in that restricted Boltzmann machine. That is the beautiful thing. That's why it's called deep learning. You see, and unfortunately, that they threw that idea and this one and so on, and then went to this DNN from 2012 onwards. That's where we are stuck, DNN and deep learning. So that is the evolution part. Let me, I don't know, time part. Can I take another 5 minutes? I think people also, those of you are getting bored, you can, oh, that's not a, so the point is whatever. So that is the AI from science. What was initially called as science, because there was some engineering that took place in between. That is from 60s, 70s to 80s or 85. That is called engineering. I don't know how many of you have read Herbert Simon's book called The Sciences of Artificial. The Sciences of Artificial. You can type on Google, you will get that book free, you see. And it's only about short book, some 150 pages or something. The point here is, you are able to inject this knowledge and so on, build systems and so on. That is all your idea, isn't it? But although it is engineering and you are building, he says, what is the science behind this engineering? That is the book that he has written. Very beautiful. So that means AI went from science to engineering, and now we are, last 10 years, in the technology. Technology means whatever I said, data, huge computing power, nothing else. So now I am coming to the next topic, human learning, ANN learning. I already mentioned that, but human learning, it always learns from pattern processing, never data processing. See? And human learning is a continuous process. And human learning is an online process. You don't collect all the things book together and learn. Suppose I give you 1,000 books today. What do? You will run away, let the books be there, that's all. Because you can't read them. You see? You see the point I'm saying, human learning, and also you don't collect all of this and learn. As and when I speak, you learn. As and when I read, you learn. So that is the human behavior. And the most important, this I need a lot of time to explain, but I would like to say this. There are two things. First of all, I think human, when I am talking or you are listening to me, the biological architecture is not a static one. It's a dynamic architecture. Every instant, it is changing. Every instant, it is changing. You see, it's a dynamically reconfigurable architecture. What it means is, the weights that you are talking about, neuronal connection, those are also changing. If you only take this subset of neurons and not that subset, the weights, so the weight space itself is changing. In learning process, the weight space is changing. These are not well polished presentation, but I think these ideas I got in the last 2 days. So, and on the other hand, ANN, you need an architecture for each pattern recognition. You have to define the pattern recognition task. That itself is hard. But once you define either a classification or a mapping or whatever it is, you need a ANN model or a stability, plasticity, element, temporal processing, all of that you can take. For each one, there is a separate architecture. I can reel out any number of avalanche architecture for temporal processing, neocognition for pattern variability, and so on. So there are dozens and dozens of. Once you say architecture, once you come up with the architecture, problem is solved. Programming is somebody else's problem. See, coming architecture not only structure but the learning algorithm. That's why there are estimated 7,000 to 10,000 learning laws in those days. Because each architecture requires a learning by itself for you to complete the architecture. So that is the architecture that you have, and the learning is coming up with a solution to the problem, or there is nothing like a the solution there. You see, so that is the ANN part. And the learning of that, everything, you see, perceptron learning is the only beautiful learning where you can come up with a solution in spite of the fact that it is a set of inequalities and so on. You could not do it for a higher multi-layer one for the simple reason that perceptual learning directly doesn't work. Even today it is a challenging problem. If any of you are, we don't know whether a solution can be obtained or not. If we can come up with a solution for a multi-layer perceptron, please note that perceptron means hard limiting. You will get almost a Nobel Prize or equivalent of that. It will be a break. So somebody said, oh, don't do all of that, make this hardly, slightly adjust Baba, like this they will say, and that hard limiting one, they made it continuous. The moment you make it continuous, you can see half-field capacity theorem, the performance drops down drastically. Performance of a pattern storage drops drastically. The capacity of neural network drastically. But you say, so that is what, because you need a differential function. That is where the back propagation came. Paul Webrose, he didn't think of all of this. His PhD thesis in 70, he wrote for something else this idea. What he said was, I have a mean squared error function, don't worry about it is a linear model or something, and don't worry about whether that is a smooth parabolic function or something, just take a derivative. What do you mean by taking a derivative for a rough curve like this? That's why almost everybody kept quiet and nothing, but he said, forget about the error surface, just take a derivative. That is the breakthrough result. You see, if you don't explain and take something, and that's all. That is where the neural network field, they were so-called back propagation. Even today, that is what it is. So that is artificial. So coming to artificial neural network, the architecture is specific to a problem, and the solution learning is simply trying to adjust incrementally so that you satisfy the inequalities if you can really satisfy them, and so on. And notice that it is the weight space for a given architecture is fixed. So the weights, only weights change, but the weight space is fixed. As I told you, last 2 days only, yesterday only, or in fact, mostly today, this morning in flight, I was thinking about it. So these are not well polished presentation, but weight space. Now go to the third one. You must distinguish between human learning, ANN learning, and machine learning. Machine learning doesn't have this characteristic of ANN. You see? So machine learning simply means, you see, that's why ANN doesn't require that much of data. You see? Because, so machine learning, I simply have maybe, as some of you projected, some 3, 4, 5 or dozen architectures and so on. Keep pumping the data as much as you can. Otherwise, use the GAN to generate data. I mean, I am awestruck to understand, although it is working, success is a rare paint which masks all ugliness. That's exactly what is happening now. You see? Otherwise, you scratch your head and say, how can you generate new data from even GAN? which has the pattern variation of a natural system. I don't understand. But it is true. Please note that I'm not passing any negative comment. I'm trying to analyze these problems. You see, I may be wrong, but the point here is that is what it is. You see, so now machine learning. Machine learning simply means you need large amount of data, and for a given model, nonlinear model. Unfortunately, since I happen to know a little bit of neural network, I can't call that as a neural network. But otherwise, it's a highly nonlinear model with dozens and millions. And now, only last week or 10 days back, I heard that somebody, Google, I think, they don't have any other work to do. So they used 1.7 trillion parameter neural network to train the model and so on. You see, all that is nice, I think they can do it, but and they are getting great performance. So as I told you, I am not disputing that at all, but I can't see why should that is the only, should we think that is the only way? That is important. I am not disputing, but there could be other way as well. You see, so machine learning simply means that it is adjusting the parameters. I don't want to use the word learning. Perceptron learning is the right learning. Human learning I cannot articulate. So perceptron learning, that learning has nothing to do with this. This learning is simply, there is an objective function, you optimize or adjust the parameter. That's what you are doing. You see, that is the machine learning. Machine learning is simply adjusting the parameters to reach an objective function, to realize an objective function. That's all. That is the machine learning. And for that, you need large amount of data because you want to capture the distribution. Unknown distribution. It doesn't fit into Gaussian model, Gaussian mixture model, any other distribution. So that unknown distribution, you want to capture it by the network. That's fine. You see, and also in this context, there is a small catch here. You see, the catch here is everybody talks about this. This can solve all the problems and so on. You see, carefully observe that yes, it can solve the problem, but not the way you do. Not the way you do. So there is what is called another field. A lot of researchers are working. In fact, I was forced to sit in that evaluation of those research scholars and so on. That is explainable AI. That means what the DNN. First of all, what DNN is doing through machine learning, you call it as AI. I don't know. And second thing is the explainable AI. You want to know what the various layers are. It is doing something, but you cannot explain. You want to explain in the form of the way human being does, sorry. Because you just built a network and you are just, something is coming out of, popping out of the layer. And it is solving, that's fine, you see. There is no problem at all. But the point here is that you want to explain it in terms of a human understanding. Fortunately, I'm a retired person, so I am lucky not to worry about this. But otherwise, if I am an active teacher, I have to worry about it. Either I follow them or, I have to, I don't know. Anyway, let's not worry about me. So this is the human learning, machine learning, neural network learning. You have to put that because that is closer to the biological network, at least intended to be closer to. Whereas you may simulate it on a computer. That's a different matter. The model architecture is what I am talking about, and the machine learning. And machine learning is data driven, human learning is pattern driven, and of course this is neural network is in between. You see, that ANN is in between. So that is what. And lastly, I'll take just 2 more minutes. Sorry for you see, the last part I wanted to say is missing science, this AI. So if you go through what we are doing through this ML, DL and so on and so, there nothing is wrong with that. We are doing great, we are working great. All I'm saying, my 80-20 you apply, that's all. And so in doing this, what is missing? I had given a talk on this about a few months ago, the missing science in artificial intelligence. Artificial intelligence as we understand today. That means anything that we do with ML, we call it AI. So what is missing there? Number of things are missing. One such example, I don't have a list of that. I have it in my material, but I don't want to. One striking one I will tell you. There is what's called the selective attention mechanism, which a human being uses all the time. All the time. When you are listening to me, You are not listening to all the sounds that I am uttering. If we happen to do that, you don't understand a bit of what I am saying. You select a subset of these sounds. Rest of it, you plug it in from here. And since each person has a different knowledge of you select differently. That is a beautiful, intelligent activity of a human being. At least I can't see a foreseeable solution for that, at least not in my lifetime, you see, and even in future also. Because Fukushima in Japan, he worked on a similar thing but at a much lesser, lower level for about 20, 30 years. Now, I don't know whether he's still alive or not. You might have heard the name called neocognitron. And derivatives of that. He was then meant to something like this, you see. But selective attention. All the time, if you don't understand what I am saying, you can easily understand if you still happen to read some newspaper. I hope you read, some of you. You know what is the newspaper I am talking about, not the on your mobile. I am talking about our big morning newspaper. You see, just think how you are reading. Little bit. Do you read THE, HI and U like this, each character? Or do you read each word? The moment you do that, your friend comes, what is in news? I don't know. On the other hand, that whole 10,000 words in one page you finish in 1 minute and you get 80% of the message. Selective attention. It's a very important concept of intelligence, which I can't see in any foreseeable future to be implemented with the technology that we have. There are many other things like that, but I just want to, and another very important, there are many, but I think I will stop with this point, that you see, when I joined IIT Madras as a professor in 1980, since I am in Tamil Nadu, I am a Telugu speaking fellow, lived in Kannada area at Bangalore for 20 years. So Tamil people, you don't know, they are very nice guys. They want to speak you only in Tamil. So I thought, so the point is, I thought immediately what I did was learn Tamil in 30 days. I bought that book. And you won't believe, I am a very sincere guy in all of this. See? So I spent every day 1 or 2 hours to practicing those characters. And at the end of it, I learned in 30 days those characters. But the problem is, when I go to the road and see this banner, I can't read it. See the point I am saying? So, that is not learning. You have not learned the Tamil characters. Any characters or something, if you type it and put it, you have destroyed all the pattern information. To keep the pattern information, you should keep all those variations and observe several variations of that. Then you observe the pattern of that character, which may be different from the same character pattern that you observe. That is learning. That is pattern processing, which no machine does it. You understand my point? So that means these are some of the things which I say science. And what we are doing is technology. Both are needed. You see? So, but this science is missing in this technology. Okay? And I think I will stop at this point. Thank you very much for your attention. I think.
Thank you, sir, for a wonderful talk. Anybody has any questions?
When you do all this machine learning or deep learning and all, it looks very fancy and everything is nice. But when you really implement, it requires a lot of energy actually, even to collect data. Small amount of data also, it takes a lot of thing. And people are talking about the consciousness, right? Really, the human consciousness is like we have a lot of collected data is there. I think as soon as the newborn baby is born, they're able to learn quickly. You can. There's no comparison at all for the human, right? For a machine, right? That is working in a limited frame. What do you think? What sort of the higher end we can reach when you compare in terms of the human consciousness the machine can go up to the maximum stage?
First of all, I don't understand the word consciousness. Although I know the reason I am saying is I am very careful, at least in public. You know, if we are talking to one, I can use a lot of loose statements. But the point here is when I am talking to, I don't know what is the although, and I also know that those who talk about it in write papers and that also don't know what is consciousness. That is clear. You see, and so because that is a human ability. And you can't, anything that is human and natural can never be understood. That is 100% sure. You may take only some part of it. You see, suddenly a robot doing something, you see, we are all very happy to, if a robot does Bharatanatyam and a human being does robotic dance. Like, I don't know what we are interested in, a human being doing good Bharatanatyam and robot doing this. But we are just the opposite, you see. So that being the case, I think they're complementary. You want to make them as competitive. That is the wrong thing. You see, I think all the, even learning, machine intelligence and knowledge, it has a human attribute, but it so happened that it percolated into all this literature and technology. We can't help it, you see, but we have to learn to live with it. But otherwise, you should not have used those terms at all here. Same thing works for the consciousness. Because something that you see as a fancy, some model, no matter how sophisticated it is, you see, as long as it is coming from, from a machine, it is artificial. And that means you imagine that you have understood that. As a 20%, you see, then you see you didn't understand anything. That's the point. Please note, I think I have read a lot of articles on this. And see, people like Ray Kurzweil and so on, I heard his talk also. He wrote a lot of books and so on. I get so bored with that. You see, every time he said, we are solving all the problems in the world. We are getting a robot doing like a human being in surpassing human intelligence, super intelligence. That intelligence word you are using there is different from the intelligence word of human being. That is the point. You have to understand that. You see, because if you don't, the point here is something surpassing. What do you mean by that? That means in future you only produce robots, not human beings? I don't understand this logic at all. You see, that's some complementary thing is what you have to reckon. Both are needed. You don't ask me to walk from here to home by a bullock cart or by walk. It's 15 kilometers, so I need a transport. It's exactly like that here. You see, I think our inability, that is, as teachers, we are also wrong here. We are as teachers, not only me, all of us, and also the literature, the way it is spreading and so on. I mean, you are lost. You see, in this ocean of this, there are estimated 25,000 papers on machine learning in 2019 alone from US. What does it mean? See, that is what you see. You write, you say this is what it is and so on. But the 20% would have helped you to see what it is not. But of course, unfortunately, the scientific community don't accept those things. That's a different matter. We have to go through this passing phase, maybe another 5 years and 10 years. Afterwards, it will change. Something else will come. If I know what something else will come, that will come right away. You see? We have seen this change over the past, at least I have seen it. 50s means what? 7 decades. 7 decades I have, at least 6 decades. You see, I have seen this. So I never saw something static. It is changing so much. That's why I had to, every decade I have to change this one. Somebody gave me a label of professor of computer science. I keep on scratching my head. What do you know? You see, the point here is, but you have to, because that is one you can get students and everybody is professor of computer science and so on. You see, this is how the labels get changed, but our understanding is all. You see, but a good teaching or good research or good writing is one where you write on all sides and give the proper real perspective rather than highlighting this and not that kind of a thing. You see, all these percentages number. I mean, even now you must be feeling, I'm sure, If it is one paper, you will read. If there are 100 papers, all of them, your own paper you don't read. You see, your job is only to publish, not to read. You see. No, that is what it is. I have never read any of my papers. I think some 400, 500 papers. I don't know what it is. You see. That's why I keep saying that's all noise. You see, you have to extract signal out of it. You see. Sorry, I'm not sure whether I answered or not, but I know everything gets into a discussion like this only. You see. Yeah. Sorry.
Thank you, sir. Any other questions or doubts? Okay. I thank sir for wonderful thought-provoking discussion. Very nice to see the other front of it, and from your vast experience, sharing some of the very important aspects which are important to the researchers as well as for the growing uh, mm, persons in this field. Thank you very much, sir.
Thank you.
Thanks.
Thank you for
Thank you, sir, for coming and yeah, at the age of 80, with this enthusiasm, sharing all the experience with us. Thank you, sir.
I request Dr. RKG to give a memento to Dr. Yegnanarayana.
Thank you.